Thanks, Janice, and good morning, everyone. My name is Yugender Chikkula. I'm the manager of technology for Motiva. I cover advanced process control optimization and some of the new digital technologies. In today's talk, it's pretty generic title. I'm going to talk about some of the applications we did using, some of the modern software tools and data analytic tools. Um, so before we get into details, quickly about my company, Motiva. We are a fully owned subsidiary of Saudi Aramco here in the United States. We own and operate North America's largest refinery with a nameplate capacity of 630,000 barrels per day. We also have the largest base oil lubricant plant in the Western Hemisphere. Both of those are located in Port Arthur, Texas, and we are headquartered in Houston, Texas. Our footprint is expanding into petrochemicals as well. We recently acquired a olefins plant right next door in Port Arthur, and we're also building a polyethylene plant at the same location. And when it's completed, probably it'll be one of the largest, refinery petrochemical complex, at least in North America. And we are also into retail. We have 5,000 retail gas stations covering most of Texas, Louisiana, Gulf Coast, and going Florida to Maine along the eastern seaboard. So I'm going to talk about some of the applications we did. They're going to cover in the commercial contracts domain some unit monitoring and process monitoring side of things. Primarily, we are trying to shift some old legacy tools that have their own cumbersome problems into modern software platforms. That's the basic theme for this talk. Um, we heard so many definitions of digitalization, and in fact, I guess it was on Monday during the DTC annual meeting, there was an interesting question comment raised. Is this digital transformation completely new? Haven't been doing this for a long time. I guess Apostolos answered that in his talk yesterday evening. We have been doing this for a long time. Some of it, I guess the answer depends on which vertical you come from. At least in refining and petrochemicals, we have been doing some of this stuff. The concept is not new to us, but most of the effort has been way down at the unit level, at base layer control, advanced control, real-time optimization, and so on. And what the new set of digital technologies allows us is essentially what happens down there is decision making process, right? And some of those concepts bring them up to into the higher level in the organization to other decision making process in the enterprise. So, a couple of applications I'm going to talk about, and essentially that's what it is. You can think of it as extending model-based control concept into some higher level problem, conceptually. So the first use case I'm going to talk about is the industrial gas usage. Essentially it's monitoring and kind of doing offline monitoring. Yeah. As we know, hydrogen is vital to refinery production of fuels, and we use large quantities. And we have, typically supply contracts that are, long term with different volumes, pricing types, and different escalation profiles. And essentially, we agree to take certain minimum and maximum volumes. If you go below the minimum, you still pay the money. If you go above, the price can be few times more than depending on the situation. So it's essential to monitor usage in real time. Otherwise you'll end up paying some huge penalty. And we went back and looked at last 7, 8 years. How much penalty we were paying. It easily ran into you know about quite a few $1 million, I would say. So there is enough business case here with enough economic incentive to make whatever tool you consider to monitor this in real time. So what were we doing before? Our good old friend Excel, the workhorse. Um, Again, we are all familiar with the problems with Excel. Typically the person responsible for this activity, they are sitting in our corporate office. Every week they bring in, data into Excel. Well, part of the challenge for us was the way this should be calculated is it should be based on the vendor or custody transfer meters. That data we used to get only at the end of the month. So if you're in the middle of the month, you don't have the data for the last 2 weeks. That we need to pick up from the metering on our side. That signal need to be combined with the vendor side signal. Then you do your calculations, and there was a very cumbersome process. You can imagine in Excel. And if you're looking at a monthly analysis, you're looking at 43,000 plus rows. And the file sizes, opening and closing this file, it used to take a couple of hours. I'm sure some of you can empathize with that. And a lot of time was spent on data wrangling, not much time spent on analysis, and it was only once a week. If you were way off from the contract volumes, there was nothing we could do. It already happened. There was no real-time visibility, no forward visibility. So that was causing us economic penalty from our side. So what did we do? So we looked at new, analytic tools. We use Seek for this one. The great thing about Seek is it connects to your historian, so there's no data import. That problem is solved. And secondly, as I said, we get some of the signal that we want to look at comes from the vendor side, so that resides in a CSV file. And this being a modern analytic tool, it can connect to multiple data sources. So no problem, picking part of the signal from Pi, part from your Excel type data source. And you have underlying a powerful math engine. You can create some predictive models, some rudimentary predictive models that can give you some forward visibility. So we use all these features to basically develop a tool that gave us real-time visibility into what's happening with respect to our hydrogen consumption. And we know where we need to be, and we can also project into, based on our monthly operating plan, how this is going to evolve over the next few weeks. So, that gave us handles to adjust takes from different vendors and, keep within the limits. Obviously, we had good success with this. As I said, it has a pretty big economic impact. And the obvious next thing to do was look at, other gases. So that's what we did, and extended, same framework to, monitoring constraints on other contracts. Another interesting thing we observed was we are not only getting forward visibility, we can also use this information for planning purposes. In the sense, let's say we are considering some unit changes. There may be a test run planned, and now we can kind of use this tool to see how it impacts my contract size. Is there a significant economic penalty there? Are we better off postponing it for a week or something? Previously, this information never went into that kind of consideration. So that's the application on the industrial gas side. And as I said, we are looking at all legacy tools, Excel tools. We had good success in those two cases. Now we went and inquired what are the other pain points in the industry where people are struggling with old tools. One of the things is the monthly report our unit engineers have to put together at the end of the month. Typical work process, bring in all the data, then massage it to take out any any issues in the instrumentation or when the unit was down, and then make sure your metrics reflect the reality. And typically this took a day or two, depending on the size of the unit. And these spreadsheets were built over years, maybe decade. In some cases, had 45, 50 worksheets in some cases. So again, same problems, large amounts of data coming into Excel, just opening and saving a very frustrating aspect. So again, same thing we did. We put it into the new analytic platform, and again, as I said, with Seek, you get a live document, and you want to see what happened this week, last week. You just change the timestamp, boom, your calculations are done in minutes compared to hours. So that's again, how the new analytic tools are helping and increase productivity. So I want to mention this another aspect in Seek, which is called causal maps. If you spend any time in control rooms as part of your control engineer assignment, I'm sure you encounter your share of cycling loops. This could be because of a valve degradation, valve friction, maybe just the tuning is not right for where you're running, or it could be some other loop driving this behavior. So how to investigate this? The easy way will be to just put things in malware and see if this cycling disappears. Or if you're looking for a non-invasive way, traditionally we look at correlation analysis. But the problem with correlation is not causation or need not be causation. So these causal maps allows you to do analysis on these kind of issues. There, the red dot is your dependent variable. The blues are independent variables, and you process this through the diagram. It gives you information where it indicates the causality as the size of the arrow, and then you can prioritize how your investigation should proceed. So yeah, that's pretty much I had. In conclusion, I just want to say, we talk about machine learning, AI, deep learning, and all those. But from a user standpoint, sometimes even modern software platforms, even with limited functionality, where it's easy to connect to multiple data sources, quick and easy, where you can do the data conditioning, data mining, quick and easy, and build some simple correlation models, quick and easy. Those kind of tools can make a lot of difference. And these we conceive these tools to be limited to engineering problems, but the the problems that exist in other parts of your organizations, this tool can make a big impact. So we'll keep looking for opportunities like this. Thank you.